Afternoon. How's everybody doing? Good? I can't see you, so you have to yell. Good. Everybody had a good lunch? My name's Rich Rollman. I'm the lead program manager on the XML technologies team. My team builds the XML core parser, XSLT, and we also build the XML support in SQL Server. So when we ship the XML support in the IE5 box and subsequent releases, what we heard from a lot of people was, we know XML is about data. We know that it helps us build our applications better. It helps us build more robust applications. But how do I get data out of my database? And we said, well, you use ASP pages and you run a query, you get a record set, you build XML like you would build HTML, and then you send that XML to wherever is requesting it or wherever you need it. And people said, yeah, we can do that, but it's not that convenient and it's not that performant. So he said, well, we can do better. And so what we set out to do was give you the capabilities, whether you're a SQL programmer or an internet or a web programmer, the ability to get XML data out of SQL Server. And so when we looked at this problem space, we tried to decide what we should do, and we looked at what things people were doing where they needed XML and they needed to build their apps with it. And the common thread that ran through people's requirements were that what they really wanted to build was loosely coupled systems. And by loosely coupled, I mean where there's no strong dependency between the server and the client, in this case the server being a database in terms of SQL Server, but that there was some mapping that occurred both in the server and the client. And what was agreed upon between these two systems was an XML grammar. And that XML grammar was able to be shipped across the wire and then taken by the receiver, run through a map, and then used with the internal data structures of either that application or the database. So think of this like you used to build programs with class files. And if you wanted to extend the class, you could add another member on the end, or maybe you wanted to add it in the middle. When you transmitted data, binary data for that class, you broke your program, because really what was happening underneath the covers was you had accessors that were at offsets to the data inside that data structure, inside that binary blob that represented that class. And what XML did was change all that, and it changed it by letting you access the data by named or through named accessors. And so what we're doing is exploiting that capability here, giving you the ability to output XML data from your database into your application, only agreeing upon that XML grammar. So your database can change its structure and how it stores the data. You can even change where it stores the data. Your app, since it also agrees on that data, can change how it manipulates the data without necessarily putting a requirement back on the database. And finally, we're doing this in a standards-based way. So you can build applications in any environment that you'd like that depend on this XML. So just to give you a little context and where this ties in with the .NET focus here, is .NET has the core of .NET is XML. And so we still need the abilities to get our data into XML format so that it can be used in the .NET framework. And SQL Server is a prime place to do that. So drilling into just the two scenarios where we look to provide support and provide capabilities in this first release of the XML support in SQL Server, we first addressed web applications with dynamic data. What do I mean by this? Any web page that you go to where there's a database behind it. You go and get a stock quote. You go to a news page where you have news items or headlines, where all that data is being pulled from a database and being displayed. any e-commerce site where you issue a query or you say, show me, the top 25 books, and you get back a listing of that data. That data came from a database somewhere. So giving the ability to write those applications where they're robust in light of changes back to the database. And secondly, and perhaps even more importantly, business-to-business data processing. So the ability to take XML or take your data, interchange it with a partner, either over the internet, across enterprises, or even within the same enterprise, but doing it in a way where you can build your applications robustly in a loosely coupled fashion. So this is the agenda for the talk. What I'm really going to show you here are primarily two things: how to query XML from SQL Server, and how to take XML and update your database with the data inside that XML. And we have multiple ways to do that based on whether you're a web programmer or whether you're a SQL Server programmer. Now, I assume everybody knows XML by now? Yes? Come on, guys. Yes? Okay, so 180 seconds just shrunk. So let's start with the architecture that we use inside SQL Server and within IIS to give you the capabilities to get XML from SQL Server. So the first thing we wanted to do to enable these web scenarios was provide HTTP access. And we originally envisioned this inside the server itself. But we couldn't build that for this time frame, for the SQL Server time frame. So what we did was we built an ISAPI DLL that will run inside an IIS server, either a 4.0 or a 5.0 server. And that ISAPI DLL is used to access the database and to provide HTTP access. What I'm going to show you further on in the next couple slides is the HTTP access mechanisms that we support. So that ISAPI DLL then builds up on top of capabilities in the SQL Server OLADB provider. And inside that OLADB provider, we've enhanced it to be able to take an XML result from the database and stream it out to the client. In the case of our ISAPI, we stream it back to the HTTP request. But because it's in the OLADB provider, you get this capability not only in the ISAPI, but through ADO, if you're an ADO and a script programmer, or you get it through OLADB if you're a C++ programmer. And finally, we've implemented support directly inside the SQL Server engine to extend the SQL language to return XML from a query, and to have the capability to take an XML document, chop it up, or what we call shred, and store that data into SQL Server. Now, what I'm not going to show you here is how SQL Server becomes an XML store. We are thinking about that and working on capabilities to do that. But really the vision here for SQL Server 2000 is getting your relational data into XML format and storing your relational data or your XML data into a relational database. And we think this is very valuable because you have a lot of business processes already running on your database. You have a lot of legacy applications. You have report writers. You have forms. You have all kinds of things that run. And it's not practical to go and replace all that infrastructure all at once. So we're giving you the capability to continue to build and use your systems as you make this move towards an XML-centric world. So the rest of the talk is very demo-centric. So I have slides, and I'm going to speak to the slides a bit, but I really want to jump into the demos and show you how this stuff works. So all the things that I'm going to show you are available in SQL Server 2000 Beta 2. So you can pick this up and run this now when you leave here. I don't believe they put SQL 2000 Beta in your bags, but you can get the CD, order the CD off the website, and run everything I show you now. And the demos will be on the conference CD. So where we start with is HTTP access. How do I get data through HTTP to my client? Well, we support a whole bunch of URL kinds of queries that we use to do these. And what I'm going to do is drill in here and show you each of these queries in detail. So the first type of query is a URL query. And what we mean by this is it's where I'm putting the SQL select statement or SQL statements directly in the URL as a parameter. So as you can see on the slide, I've got a SQL parameter that I put to a virtual root. That ISAPI DLL here is configured to run for a virtual root in IIS, and all requests to that virtual root are processed as if they were made to SQL Server directly. And what I'm able to do is pass a SQL query, and the returned result is an XML document with the columns that I selected in that SQL query. Now, this is not the loosely coupled system I'm building here, because in a loosely coupled system, I insulate the caller from the data. But this is a really good developer feature. It really allows you to get moving quickly and to start getting data out of SQL Server in a very quick fashion without a whole lot of work. So you can experiment, play with it, and understand how the support works. Some of the other things that we allow you to do here is specify an XSL template to run on the query result before you send the data back to the client. And that XSL style sheet will live on the server and be executed with the data from SQL Server. We do content types and encoding, so we support international character sets. And finally, we have a root parameter that just tells us to wrap an enclosing root tag around the XML that you return. This is useful since queries can return XML fragments, not complete XML documents. So let's see how this works. Is that readable? I don't think I can make it any larger. So the first query I'm going to show you is just simple to the Northwind database. It just selects all the fields from customers, and it builds XML. I'll talk about this for XML syntax on the query in the next couple sets of slides once we go through the URL access. But if I click on that URL, what happened was that query on the URL was run against SQL Server, and SQL Server generated the XML and returned it to the browser. So I'm just using the browser's capabilities here to display XML as a way to exhibit the XML coming back from the server. I could well have written this in VB or any other application environment and gotten the XML back through HTTP in that way. But I'm using the browser here because it's a convenient way to show you the result. So what happened was I was able to query the database, and I built customers tags with the column values as attributes of the tag. Sorry. Now, where this gets really interesting for that dynamic data web application piece is I can go out and query that data I want, and then I can style it. So here I'm just going to add an XSL parameter to allow to say, run this transform on it before you return that data back to the browser. And instead of getting an XML document back, I can now get an HTML page or however I wanted to format that data. I could well have put it in list items or whatever else I wanted. I'm just generating HTML. If I view source here, you can see this is just a standard HTML page. There's no XML here. The whole transformation was done on the server, so it's a browser-neutral way of getting data back to a browser. We're not dependent on IE here. You could put a style sheet programming instruction in the page and bring it back, and I'll show you how you do that with a template to do the transform on IE if that's what you want to do. But you can also do it on the server in a browser-neutral fashion. I'm going to assume that everybody knows what XSL is, and I don't really have to drill in there much. You can pick up the demos from the CD and look at the XSL style sheets. Or a lot of you I know have attended Don Box's presentations earlier in the week, and I know he talked about XSL there. The other cool thing that we can do is if you really don't like to run ad hoc queries against your database, you can also use stored procedures. to return XML. So in this demo, I'm just going to exec a stored procedure called mySproc, and I pass it a parameter of a state. And when I execute that, we've gone off to SQL Server, executed a stored procedure that took that parameter, ran a query against the customers table, and retrieved only the customers from the state of Washington. So this mechanism also extends all the way back into the server, allows you to use stored procedures to return XML. And finally, I can pass parameters. In the URL query, I pass parameters positionally on the SQL statement. So I use question mark syntax, and then we just use any of the parameters. We ignore the names, and we just use the positions of them in the URL to put them into the query. So in this case, I want just customers from Seattle, Washington, and I get that query back, the query result. Pretty cool stuff. So when we were looking at that dynamic data web application scenario, one thing that people told us that they wanted to do was when they were building their databases, they had a need to store some image data in the database. The classic example is an e-commerce site where they want to build from a query a web page with a picture on it. And so what we looked at was a way that we could take a blob column in the database and return it in its native format through HTTP. And so we call that a direct query. And what a direct query does is exposes the structure of the database as if it were a large XML document or a virtual XML document, one in which the tables or the views inside the database define elements, and the columns of those tables and views define attributes on those elements. And then we're able to formulate queries inside the URL using XPath syntax on that virtual document to retrieve data. So let me show you how this works. So in this query, this DB object notation tells the virtual root, this is a direct URL query. I'm saying /employees, which says find the employees table. Square brackets in XPath, if you don't know, are predicates. So it says find the employee ID attribute where the value is 1, which maps to find the employee ID column with the value 1. And then I say / and @ last name says return the last name attribute or the last name column in that table. And if I execute that, I get back a single text value. Now I'm showing this in the browser, but it's not even HTML. It's just a simple text column. Because that column that I queried, last name, was just a character column in the database. So that illustrates it simply. Now I can do the same thing and get back a photo column. And the photo column is an Ole picture object stored in the Northwind database. And I can just say, open this file. And so what IE does is it looks at the data coming back and tries to recognize it. It does, and it says the way I display this Ole picture object is in the Paint program, and it brings up that Paint program to display the image. So direct queries are very useful for getting single row, single column data back out of the database in the database native format through HTTP. And I'll show you how we use this further on when we talk about the query syntax itself, the extensions to the SQL language. The third type of mechanism that we allow you to query the database through URLs is templates. And this is really the meat of the support for loosely coupled systems. You can think of a template like a middle tier stored procedure call without really having to write any logic. So what a template is an XML document. And it can be there can be arbitrary XML in there. But what we do is we look through that XML document searching for embedded queries. And so when we process that document, we echo back any of the XML elements that we don't understand, and we take the queries that we find, we run them against the database, and we replace the query in the template with the query result. And so this becomes a very powerful mechanism to allow you to be able to expose functionality out of your database without writing stored procedures and keeping the support on the middle tier. Like the URL query, it supports XSL and the encodings. So I'm able to take and run a style sheet on this template before I return it to the requester. And finally, templates support parameters. So I can pass name parameters into templates, which is a very powerful mechanism as well. Let's see how this works. So I'm going to show you some demos of template queries. So my first template is very simple. It just takes that same query that I put on the URL and puts it inside a template. And so here's the template with an embedded query. We're using XML namespaces here for our query elements. So when we process this document, we're stripping out the tags and the attributes from our namespace and echoing the rest. So let's execute this template. Again, I'm just using the URL to the virtual root. The little t is something called a vname. It's a level of indirection in the URL that indicates to the vroot that this is a template. And simple template is the template I just showed you. So when I request that as a URL, what I get back is the result of taking that template, processing the queries, and returning the result. So pretty cool stuff. Again, I can style it with an XSL style sheet. And we allow you to embed that style sheet directly in the template via the SQL:XSL attribute. And the value of that attribute is an XSL style sheet that should be run on the result. And when I run that, in this case, I didn't do a transform to HTML, but I did an XML transform. So an XML to an XML transformation, where I took the city attribute and I made it an element, and then I put the customer ID and the customer name as sub-elements of that element. So it's a powerful way as well, and if you're not generating HTML, but you need to perform some transformation or something that the database just doesn't conveniently provide a way to generate that XML grammar, you have the ability to run XSL on it as well to do arbitrary transformations. So let me show you quickly a template with parameters. So to allow parameter declarations, we introduced something called the header element in the SQL namespace. And inside that header, we define param tags, or the parameters that are used on the URL when we send the request to SQL Server. And the content of that param element is the default value to use. So if the parameter is not present on the URL, we substitute that value. And then what I can do is use that in conjunction with the query and a standard T-SQL syntax, or standard T-SQL variable syntax, to declare city and state. And when we execute this template, then we replace those parameters into the SQL as we run the query to get back the appropriate data. So here I passed the state of Oregon with no city. If you remember the template, the city was all cities, or the % character as a default. So what I get back is customers from the entire state of Oregon. I could change this on the fly just so you don't think I've got all the demos previously baked here. I can go for Pennsylvania. There's no data in the database for that. I don't know if there's anything for Florida. Nope. Certainly something for California. So I'm running live queries. I have SQL Server 2000 running on this machine, as well as the PowerPoints and the demos. And finally, nothing to spend time on, but I can also, using that same XSL processing with a template, generate HTML as a result of my query. So there's a fourth mechanism that I can use to access data in the database, and that's an XML view. But I haven't defined what an XML view is, and I want to wait until further on in the presentation to do that. So we'll come back to how you use XML views within a URL. So a common question that gets asked when I show all this URL access is, this is really cool, but how do I secure my database, and how do I prevent people from doing things that I don't want them to do? And so we've implemented security on the virtual root inside SQL Server. Inside IIS. And what we allow you to do on that virtual root is define the permissions that will be used to access the database. And you have three options. You can use anonymous access, where you set the Windows ID password or the SQL Server ID password on the virtual root, and that ID password is used for each request to SQL Server 2000. This, I think, is the most common method that people will use because it allows you to have the tightest control on security. Second method is basic authentication, and this allows you to in a browser scenario, to get a prompt for an ID and a password. It's clear text, so you should run this over HTTPS. But what we allow you to do is provide a SQL Server ID and password, and then we'll use that for authentication to access the database. And finally, we do integrated security with Windows. So we give you the ability to pass a Windows ACL right from the client all the way through to the database. So one note on security before we leave. The queries that I showed you, especially in the URL query where I say SQL equals, and inside the template, that's full T-SQL. So I can put multiple statements there. I can put drop database there. So please do not go out and enable an arbitrary user with full access permissions to run this HTTP access to your database. Lock down the IDs, use the security we've provided, and you'll be fine. So to summarize what I've showed you so far is how we use HTTP to get data from SQL Server. So we can take that data, move it through firewalls, get it out in a standard XML format that can go cross-platform, and really build those loosely coupled systems that I talked about. So through all that, I kept showing you this syntax on the SQL query. This syntax that says for XML. And what this allows me to do is say, don't return a standard result set. Instead, return XML as a result of this query. So the first question should be, well, geez, what XML do I return? XML is a very rich format that allows me to define arbitrary grammars. How does the database know what grammar to generate for that query? And we give you three options directly on the query to do this. The first option is raw mode, and it's the simplest option. And what it allows me to do is say, for each row returned from the select clause from the query, return me a single row element where the columns returned for the query are the attributes on that element. So very, very simple XML. Not really what I would consider to be, true XML. Because if I do a join, like I'm going to show you here, where I take a query, I select customers, the customer ID, and the order ID, and I do a join on the customer ID between the orders table and the customers table, what I get back as a result of that query is essentially a rectangular set of data where each row is represented by a row element and the columns by the attributes on that element. And I get a lot of repeated data here. So you may be saying, if this isn't really XML, what good is the raw query? Well, if you're going to run an XSL transformation on this, it's pretty simple to write XSL against this output. Moreover, we have a style sheet that you can use with this output that will transform this into the ADO persistence format, if you're familiar with ADO and its ability to save XML and load XML. So raw, in my opinion, is not terribly interesting. Where things really start to get cool are when we move to auto mode. And auto mode lets me take my query to my database, and it looks into that query and figures out how to nest the XML. And so instead of generating row elements, it looks at the tables or the views that are accessed in that query, and it uses those for the element names. And it looks at the columns accessed in there, and it uses that for the attribute names. If you subscribe to the point of view that attributes in XML should be represented in sub-elements, so if I have an order and I have order IDs and amounts of that, and I subscribe to the point of view that that should be sub-elements of that order element, you can also do that with the elements directive. So we aren't religious about how we produce our XML. You can produce attribute-centric or element-centric. It's your choice. And then we nest queries that have joins in them. So we look at the order of the elements in the select clause, and we look at the tables they reference, and we nest tables from left to right. So let me show you how this works. Sometimes seeing it is easier than explaining it. So here's that same hierarchical query that I did for raw mode, except now I've just changed it to be an auto mode query. Oops. Everything is still the same. So let's execute that. And now what I get back is the orders nested inside the customers. This starts to feel like XML to me. It starts to feel like we're exploiting those hierarchical relationships in our data directly inside the representation. So to show you what I mean about how we nest, how we determine the nesting, I'll now take that same template with that same query, and I'll reverse the order in the select clause. So what I did is I put the order ID first, followed by the customer ID. And when I execute that query, now I get customers nested inside orders. So it allows me some control of my XML grammar through the actual SQL query. Now there's a limitation to this, and I'll show you that here, is that we're always going to nest. So if I add an employees column or the last name of the employee who took the order, what I really want is the order, the customer it belongs to, and the employee that took the order. So in this case, customer ID and last name are intended to be siblings. But when I execute that query, we nest the employees table inside the customers table, which is nested inside the orders table, or the orders element. So this is a limitation of auto. We are always going to nest the queries. Moreover, if I went through an intermediary table where I just used it in the join, but I didn't reference it, we're also going to generate elements for that as well. So it's flexible, but it doesn't give you the ultimate control over the grammar you need. Another nice thing we do is we allow you to use the XML data clause in conjunction with for XML. And so using that with that same query and executing, what this allowed the database to do was generate an inline schema. So here I generate an XML data reduced schema inside the result. And this is convenient if I want data types from my database to be exhibited through to the XML. So here I'm declaring, I get the data type declarations inside the schema. I can also use this to generate schemas, and I could take this result, cut and paste the schema out of the result, and use that as well. So it's a convenient way to generate XML data reduced schemas. And finally, I mentioned when I talked about the direct URL query that I would come back and show you how it's used inside that dynamic data web application scenario. And so what we do in an auto query, and in this case I'm going to query for the photo column of the employees table, is instead of returning blob data into XML, in this case an image into XML, where we would have to encode that image in some text-based format. Mainly the two formats used in XML are bin hex and bin base 64. We actually instead generate a direct URL query. So I generate a photo attribute which has as its value another query that I can run against that same virtual root. And where this gets really interesting is when I marry it with a style sheet that produces HTML. And in this case, I produced, for that photo column, I produced an image tag where I set the source value equal to the result of the query. And so you can display the images directly in the page. Now, if you have something in the database in that column other than, say, an image where you actually want the binary bits, you can also get that, and you use the binary base 64 directive, and we'll actually generate the base 64 encoded data for you as well. So if you're storing some object in your database that you want to instantiate out of a storage object or something, you can do that as well. So we give you the flexibility to use it arbitrarily. So the auto mode gave me some capabilities to control the grammar that I generate out of the result of a SQL query. What I want to show you now is the last mode, or something we call explicit mode, that allows me full control, arbitrary control, over the grammar. So I can control everything about the XML that gets generated. Now, the downside of this is that to get all that control, you'll get complexity with it. And so with an explicit query, what I'm able to do is control whether data values from the tables that I select are used as an element or an attribute. Now, I was able to do that with the auto query, but it was all or nothing. I either got all the columns as sub-elements or all the columns as attributes. Here I can pick and choose. The other thing I can do that's really cool with an explicit query is I can hoist hierarchies. So I can go through intermediary tables without those tables showing up in the output XML. So I can take, for example, in Northwind, I can put out a list of orders with the order items where instead of getting the order item, I get the actual product name and put it in the list, which would go through the order item table as an intermediary. It also lets me build ID refs. These are just a way of doing primary key, foreign key in XML. So an explicit query lets me generate ID refs attributes and ID attributes. It supports C data, which just avoids the encoding in XML. And it allows me to retrieve any XML annotations that I may have stored in the database. And I'll talk to you later about, when I talk about our OpenXML support, which is the way to take XML data and store it back into the database, how this works. So we have a way for you to take XML fragments, put them in the database, and then get them back out on a query. So I'm not going to spend a lot of time on for XML. I put the slides in so you could take a look at this on your own, but it takes a long time to explain this. I'll try and go over it just on a very surface level, and you can drill in. So I approach this from a different standpoint, or from here's the grammar that I want to generate. I want to generate a root tag that has customer tags within it, where it has a name, sub-element, and then orders corresponding to that customer. And so what I have to do conceptually with the explicit query or with the SQL query that I write is generate something we refer to as a universal table. Or I have to generate a rectangular set that represents that XML. And you can sort of see the hierarchy here, where I get a customer and the orders below it. And so what I have to do is generate a SQL query that does that. And so here's the query that does it. And it's a little complicated. It generally involves doing unions of multiple queries together to construct that universal table that I showed you. And it involves using these funny column names. And these column names tell the query processor how to build the XML that you send in. So we use these encoded column names to tell us how to control the XML. I'm not going to drill into it here, but I will show you some of the capabilities. So I mentioned for the 4XML auto query didn't support siblings. So I wasn't able to get back that employee inside the order with the customer. With a 4XML explicit query, I can. The query is a bit more complicated, but you'll see as I execute this template that I do get back employees directly below the order like I wanted. So it gives me that arbitrary control that I need to run the query. It can generate ID refs. I won't bother with the query. But what you can see here is a set of orders where there's a products attribute or an ID refs type attribute on it with ID refs inside it. And if I drag down, you'll see that orders is followed by product elements, where that ID that's referenced in that products attribute on the order are the IDs on the products. So if I were writing XSL against this or doing DOM processing against this, I could use those ID refs attribute, that products attribute, to navigate from that order to the products that order was composed of. And I'll skip the annotations demo. You guys can look at that on your own. So to summarize, 4XML is the SQL-centric way of building XML as a result of the queries to your database. It's really geared towards SQL programmers. It can be geared towards web programmers if web programmers know SQL. But in general, this really fits and is a good migration strategy from where you are today with your database access using SQL language to get that to generate XML. So now what I want to do is kind of switch gears and take a web-centric approach. And our web-centric approach is something we call XML views, or mapping schemas. And what an XML view is it's a definition on the database that treats the database like a virtual XML document. So it's similar to how I described that direct query, but it allows me to define arbitrary grammars on top of my database. And we do that using the XML data reduced schema specification, and by providing the mappings, a mapping directly in the XDR schema that maps to the database. So how an element maps to a table in the database, how a sub-element of that element maps to a column in that table, or how an attribute value is mapped to a column in the table of a database. So it gives me the ability to do this. This basically an XML view on the database. Moreover, it lets me define hierarchical views. So it lets me specify relationships of how a hierarchy in XML is represented as separate tables or views inside the database. And then what we can do is take that XML view definition, marry it with an XPath query, and generate XML results from the data inside the SQL Server database. So here's an example of a mapping schema, or an XML view definition. What it allows me to do is take this element type of customer and provide this annotation that says all customer elements in this view map to the customer's table in the database. We use the term relation because it maps between views or tables. On this attribute ID, I say that maps to the customer ID column, and we inherit the definition or the customer's table from the hierarchy inside the schema itself. I do the same thing for the orders element, and then in the content model of that customer, on the order element, so the schema is saying that a customer can contain orders, elements, I provide a SQL relationship. And really what this is it's pretty much a join clause that I would use if I were going to access the database to relate that customers table to the orders table. And how do I represent that? And so I provide the key and key relation and foreign key attributes on that relationship tag. Now, those don't have to be foreign keys or primary keys in the database. They can be arbitrary columns. Moreover, if I have a multi-column key, I can express that by including space-separated column names in the key values. And if I have multiple tables that I need to indirectly go through to access the data, I can also specify multiple SQL relationship tags for a single element. So I take that view definition and I marry it with that XPath query. In this case, what I'm showing is I do the XPath query /customer where the ID attribute is equal to alfkey. So I treat it just like it's a virtual XML document where the customer element is the root element, and I query it. Now, one interesting property of XML data reduced schemas is they don't specify a top-level root element. There's actually n possible root elements where n is the number of element types declared in the schema. And so we actually leverage that, and you could do /orders and you'll access all the orders in the database. If you do /customer/orders, then you only access the orders that have a related customer in the database. In general, people maintain that referential integrity, but if they didn't, you could get different results from the two. And in general, when you ask for /customer/orders, you're going to get the orders grouped by customer. So now that you know what a view definition is and how we query it, how can I do that through a URL? Well, there's two options. There's either directly in the URL, and I do that by specifying a reference to the mapping schema directly in the URL, here represented as this vname. So the virtual root knows this is a virtual XML document query or an XML view query, process it that way, and then I specify XPath directly in the URL, and followed by the parameters that I talked about before that can be used, including XSL. Let's see how this works. Very simple mapping schema, a single element type called customer that maps to the customers table. Point one more thing out here. On the attribute for address and city, I haven't specified a mapping. We actually provide a default mapping. So if you don't have a mapping on here, we'll assume that the name corresponds to the name in the database. And what I can do is then run this URL query, which is /customer. And I'm running the one that has the root parameter on it, so it gives me a wrapping root tag, so IE doesn't complain about a non-well-formed XML document. But you see what I get back is the XML from the table from the customers table in the database. So this is an alternative as well to using explicit mode queries. So if you think it's too hard to build the SQL query that does the explicit mode, that you would run in explicit mode to get that arbitrary grammar back from the database, alternatively, you can define an XML data reduced schema and the annotations to the database and then just query it through XPath. Now, we don't support all of XPath in this release. We've done a minimal set of the XPath syntax that very nicely maps to SQL Server. There's a lot of peculiarities in the XPath definition that don't correspond well to how relational databases work. So we're going to continue looking at this, but we're also looking very hard and participating very strongly in the XML query working group that's going on in the W3C to define a unified query language. And we plan on supporting that when it comes out. So we also didn't want to innovate in XPath to cover some of the things that weren't basically built into XPath from the start. So you will find some limitations here. But I think it's still a pretty powerful system and allows you to do most of the things that you want to do. So I can also do hierarchies. So just a couple of quick demos. This is a little more complex schema where I have an element type and an order. So basically the one I showed you on the slide. If I run it, I get back the result I would expect, customers with nested orders. And I can also do that sibling case. So instead of defining that XML explicit query, I can build a schema, or if I already have a schema, in a lot of cases, when you know the grammar you want to generate, you probably already have a schema for it. I can use the schema to represent that same case in here, saying that the order element has a customer and an employee. And when I execute that query, I get back that desired sibling relationship inside the XML. So again, a very web-centric, very XML-centric way to access the data in your database. So because we're about loosely coupled systems, because we think building loosely coupled systems is important and it's a good thing to do, we also provide support for XML or XPath queries with XML views inside a template. And this is not complicated. You just use an XPath query element, specify a reference to the mapping schema, and put your XPath query in there. Now, very much like we did with SQL queries where you can parameterize them, we exploit XPath's variable mechanism to allow you to pass named variables into your XPath queries as well. So here I'm passing in the state to query against the region attribute in that virtual XML view defined by nwin.xdr. So why did we choose XDR? Well, one, because the schema effort in the W3C is not yet closed. And we needed a way to annotate schemas, and we didn't want to innovate, and DTDs were very limited in this capability. Moreover, a lot of the Microsoft products have picked up and are using XDR, waiting for the XML schema effort to close in the W3C. And so how this fits together very nicely with BizTalk, because it's XDR based, is exhibited on this slide. So this basically is just to show you that I can take a publicly defined BizTalk schema, take a copy of it, annotate it, and then use that annotated copy to query against my database. But the data I get back from my database is actually in the format for that public schema. So to summarize, this is a very XML web-centric way of querying my database, getting the data that I've stored in my relational database out as XML. And when I say on this slide, no coding required, what I mean is I don't have to write procedural code. I did all this just with standard SQL syntax or with XPath syntax. I didn't have to go in there and write procedural logic. I didn't have to write loops to do this. After all, that's kind of how we got to doing this implementation in the first place, was we didn't want to have you write ASP pages that did procedural code to build your XML. So everything I've talked about so far is how we get data out of the database. Now I want to show you how we put data back into the database. So in this scenario, I have XML. It has data within it. I want to take it, provide it to the database, and have it take the data out of that XML and store it into my relational tables. And the way we do that is with a syntax called OpenXML inside SQL. And OpenXML is a lot like OpenRowSet, if you know that. It allows you to provide a relational view on top of that XML document. And then because it's a relational view, it lets me write standard SQL against it. So I can join to it, I can select from it, and I can take the data out of it and update the database with it. And the way it does that is it allows me to specify what constitutes a row in the XML, and then relative to that row, what constitutes columns. And again, it uses XPath to do that. So everywhere where we can, we're using the standard-based ways to deal with XML to provide access to the database. So conceptually, here's what's happening. We have an XML document that contains data, and we run it through something we call SPXML prepare document, basically a parsing pass. And we parse that XML document inside SQL Server. Again, all this is now inside the server. It's not in the IIS box inside that ISAPI DLL or inside OADB. It's happening inside the server itself. We build a DOM, or we build a tree representation of that XML document, and then we're able to take and do something we call shred with that OpenXML syntax, or build a relational view on that document. And what I'm trying to show you here with all the funny colored dots is how we're able to take through XPath syntax, regardless of the actual order of the XML, again, name bindings, and build that relational view, and then operate on that relational view with SQL. Or in the case where I want to insert data into my database, run an insert into clause. So what does OpenXML look like? Well, I get to pass it a doc handle that comes from that prepared document call. So it's a document that's in memory inside SQL Server. I pass it a row pattern, so something like /customers. So find me all customer tags, and those correspond to rows. And then I get some options. So in a tightly coupled scenario where the XML matches my database structure closely, we allow you to use an existing table name to tell us how the XML is shaped. So we allow you to say, I know I've got this XML element. Its schema for the relational view defined for OpenXML. Use the customers table for that. And what it'll do is it'll look at the customers table, look at the metadata, the definitions for the column, and it'll build the view to look just like the customers table. And I've got flags that control whether that's attribute-centric or order-centric. Again, we're not religious. Or more flexibly, I get to specify a schema. So I get to say what the columns are and how they're defined. I get to say what their names are, what the type of that column is, in this case, what the database type of that column is, the SQL Server type, and the column pattern for that data inside the XML. So a relative column pattern to that row pattern. So find me the customer ID on the customer tag. And then I'm able to use that syntax in this example that's on your screen now to take data out of that XML document and insert it into the database. And here you're seeing that where I'm finding all customers inside the document, //customer as the row pattern. And then I'm defining two columns on that view, a customer ID and a company name, that come from the ID attribute and the name attribute on that customer element. So let me run an example that shows you some of the power of OpenXML. In this example, what I'm going to show you I'm going to do is I'm going to update, or I'm going to insert multiple rows in a single call. So what I can do is now I can write stored procedures that take as a parameter an XML document and do a single, and through a single exec, update multiple rows in the database. In this case, I'm just going to use a table called My Customers. I'm going to prepare the XML document. In this case, I've just put it inline. So it's this document with 3 customers inside it. And I'm going to run basically that insert clause that I showed you in the slide, but with a couple more columns used. And then I remove the document from memory. That's an important step. And when I run that, I've now inserted 3 rows into my database. So I've used XML as a way, I'll query it here to show you. I've used XML as a way to send multiple transactions to the database at one time in one single round trip to the database from your middle tier or your client and have that work. Now, time is short, so I won't show you all the examples, but the examples will be in the demo distribution from the conference. But you can do joins against an OpenXML. So I can take I can build a relational view on top of that XML document and then join to it with standard SQL syntax. I can do hierarchical updates. So I could have sent an invoice in with a bunch of line items on it, and I would be able to update both the invoice table and the line items table in the database. So it lets me do not only multiple row updates, but multiple tables as well. So to summarize, OpenXML is really, again, allowing me to leverage that relational database, that SQL language, to do updates to the data, or updates to your database. And when I say updates, I mean insert, update, and deletes. So that's the SQL-centric way. In SQL Server 2000, the release, we don't have a web-centric way. But we're building updategrams for web release, and I'll tell you about let me start over. I'll tell you about what web release is. Try and say that fast. In a slide or two. And an updategram is a way to express a change to an XML document. So again, I'm looking at the database as a set of virtual XML documents. And how do I express a change to that XML document? And updategrams allow me a way to do that in an optimistic way. When I say optimistic, I mean we're web technology. We're not going to maintain a connection to the database. So I'm going to query my data out of SQL Server. I'm going to get my XML data. I'm going to make some changes to it. Now I have to send those changes back. How do I do that? Well, an updategram allows me to do that. Here's an example of an updategram. So it basically allows me to do I put a sync tag, and I have a before and an after image. And from these two, we do a check with the database to make sure that a subsequent change hasn't occurred, and then we commit the changes that you've specified here. Now again, we're leveraging the XML view technology that we built for query, and we're allowing you to reuse that for updategrams. So we can use that XML view to do hierarchical updates or multi-row updates with a single updategram invocation. So this is not running now in SQL Server 2000. It's not in Beta 2. It will be on the web this month, probably towards the end of the month, on the XML Dev Center. And what we're doing is we're putting out a release that will run with SQL Server 2000 Beta 2. So you'll be able to play with this shortly. The dev team is working out the final glitches in it, and we'll get it up on the web shortly. So the last thing I want to talk about is everything I've showed you so far has been HTTP access to get at the data. What I want to talk about just briefly is how I use ADO and OLEDB to do that. And what we've done inside the OLEDB provider is we've invented two new dialects that OLEDB supports. An XML dialect, so that I can take those templates that I showed you and send them to the OLEDB provider and have it process them and send me back XML as a result. And provide a mapping schema to the XML provider and use XPath to query against that XML view on the database and return XML. So a couple quick examples. This is using the XML dialect or the template capabilities. And I'm not showing a full template here in the example. I'm just building a stream that contains that template, and I'm assigning it to this command stream variable. And then I set this intuitive GUID that says this is the XML dialect, and that tells OLEDB, return XML for this result. And then I get to specify an output stream. And so the reason we put an output stream parameter here is because we really want to pipeline that data as much as possible. We want to avoid copying that XML data through multiple processes. So we allow you, in this case, came from an ASP page. It allows me to pass the response object that has an iStream on it. And inside OLEDB, it'll QI for that iStream and then fill that iStream with the XML data returned from SQL Server. And then I just call execute on that command object to execute the query. Same kind of thing with XPath. I use the XPath dialect. I use command text, and I pass an XPath query. I use a mapping schema name property on OLEDB to indicate the location of the mapping schema, and I execute the query. So everything I showed you today can be run either programmatically through ADO or OLEDB or through HTTP via the ISAPI DLL. So to conclude, I want to talk a little bit about where we're going with this in the future. And the big important thing here is web release. So we are going to move the SQL XML support onto a similar schedule to what you've been seeing with the MS XML support, where we're putting periodic releases available out on the web, and at some point in time, we'll say those are supported bits. You can put them into production, you can call PSS for support, etc. The main goal here is to get technology into your hands quicker, to get designs into your hands quicker to say, do they meet the need or do they not, and to get feedback in a very interactive manner with the development community. So everything that you see on this page is going to show up in the form of web releases. So I talked about update grams. Another big request that we've heard from a lot of people are, okay, I do big data dumps and data loads into my database, and it would be very convenient, especially when I'm interchanging data with my partners, if I could do that through an XML format. So how do I take a gigabyte of XML that represents product data and load it into my database? So what we're working on is bulk load, or the ability to, again, leverage that XML view technology that I showed you, but load very large documents into the database. And this is a unique problem because it forces us to treat the XML as a large stream, because we can't possibly put that large a document into memory at one time. And so we're working on that currently, and you should see that in a web release in the next couple of months as well. We're also working on support for arbitrary data sources. So we're working on support so that you can go back and use the XML support against SQL 7.0, SQL 6.5, and we're also going to work on support for some of the other popular database platforms that people use. So the things you see here potentially could run against Oracle and Sybase in the future. SOAP support. So SOAP has got a lot of buzz right now, and it's a really cool thing. And we'd like to be able to expose to you stored procedure invocations through SOAP, or template invocations through SOAP. So giving you a mechanism to, instead of just using URLs with the parameters on the URLs, to pass SOAP messages and get data out of SQL Server. We'll also be looking to enhance the XML view support, to put more rich mappings in there, to support more of the XPath standard where we can. DAV support on the database, so allow you to use the DAV protocols to access data out of SQL Server. And finally, some ADO integration. So a lot of people, a lot of requests we hear from customers are, we use ADO as our data programming model. We want to be able to use ADO when we reach out to some site and grab XML from some customer. And we don't want to use DOM, we want to use ADO as our programming model. So if you think about that open XML syntax that I talked about, where it's defining a relational view on top of XML, we would also like to provide that inside ADO, so you could reach out through a URL, get an XML document, define a relational view on it, and then use ADO as your data access mechanisms. And finally, W3C schemas. A question I always get asked in terms of the XML view support is, what are you doing with schemas? And the schema spec is not complete yet. We're tracking the spec. We're actually doing some implementations in-house. And we're working on a strategy where we can take you from the XDR schemas that you use today and get you to XML schemas, the standard with the W3C. So in the future, what you'll see SQL Server support is XML views defined with XSD schemas or XML schemas. Here's some related sessions. I won't spend any time here. The key to get all these web releases is the XML Developer Center at msdn.microsoft.com/XML. This is where all the SQL Server enhancements for XML will be posted, as well as the MS XML enhancements. Been a great audience. Thank you for your attention. I'll take questions.
Yeah, I have a question. It looks like some of the transformation from XML to a relational model might take some computation. Do you have any kind of performance statistics or information for us on the performance of that?
So your question is doing transformations on the XML data that results from a query? Is that
yes, in SQL itself.
Oh, in SQL itself?
Yeah, transforming from XML to the relational tables.
Okay. So if you didn't hear the question, it was, what is the processor load generated for an XML query versus a standard results set query? There's a small performance penalty I don't have an exact figure to quote you. Well, we've paid close attention to this, and we've made sure that it runs pretty much like any other query. And what we generate is if you go through OEDB and access to grab XML through the mechanisms I showed you, we don't actually generate full XML on the server. We use a tokenized format that we use between the server and the OEDB provider. And that tokenized format puts native SQL data types on the wire and tokenizes the XML tags. So it's not going to run that much different. You might see 10, 15%, I would venture a guess as the figures. The other thing it will depend upon is what the grammar that you're generating is. Right? So if you compare this to outputting a flat row set, it's going to be different, but you're going to have to do the processing to build the XML for that somewhere else as well. Make sense?
Okay. Yeah, thanks.
You're welcome.
Just on the, it looked like you were building the document using the DOM. What kind of memory requirements is that going to impose on a SQL Server 2000 machine?
Okay, so the question was, if you're building inside OpenXML, I did a prepare document call, and that built up essentially a DOM inside SQL Server. What we've done is we use MSXML to do our parsing, but what we've done is we've taken the storage layer for the DOM and we've made it SQL centric. So we've put it into temp space in SQL Server, so it has disk space backed memory allocation on it. I would not suggest leaving very large documents in memory inside SQL Server for a long period of time. It can impact your performance, but we've made that backing store disk-based, one, and two, we have some limits that we won't allow you to exceed inside SQL Server. So we won't chew up all of SQL Server's memory. In other words, you'll bump into a governor inside SQL Server at a given point in time that won't allow you to allocate all the memory away from SQL Server.
What's that ceiling?
It's a complicated formula. I can't really tell you off the top of my head. I can get the answer for you if you'd like.
Are there any plans to implement any kind of caching for frequently accessed types of queries?
So the question was, is there any plans for caching for frequently accessed queries? So all the queries that I showed you, everything that uses standard SQL is going through the standard query processor. So the query processor automatically does caching on an LRU basis of the queries that run. So you'll get query plan caching. If you have stored procedures that output XML, you can get those pre-processed and cached as well.
The XML?
So we use all the standard mechanisms that SQL Server employs to do that processing. You obviously can't do that with OpenXML because the XML is the data that's coming in. It's going to be different every time.
Thanks.
You're welcome. Over here.
Yeah, there are, I guess, about 4 flavors of XSL style sheets. There's XSLT and XPath and XSL patterns and the XQL work that's going on in the W3C. And then you've got this ADO guy yesterday who gave the presentation and said it was all bullshit several times. And what I'm looking for is a little architectural guidance, both in terms of which XSL kind of features are appropriate and when it's appropriate to do transformations using the XSL and when to do them the old-fashioned way in the database. Okay.
So let me address the different flavors of XSL first. Microsoft shipped an XSL implementation in the IE5 timeframe that is not the XSLT standard. MSXML3, which ships now on the web and will go to Goldbit sometime in the fall, has a full XSLT implementation. The implementation that ships with SQL 2000 is a partial XSLT implementation. And you can select between these two by simply using the namespace that you specify on your XSL style sheet. So the difference between XPath, what Microsoft used to call XQL, and now what's the XML query effort in the W3C, are all XML-based query languages or path-oriented query languages. XSLT uses XPath as its select mechanism inside the style sheet. XSL uses Microsoft's old XQL as the select mechanisms inside an XSL style sheet. Okay, as far as guidance on where to do the transformation, there is a cost to doing an XSL transformation. It means you have to parse the data and you have to run the transformation on it. There is a cost with that. In general, what we're doing here is we're running that XSL transformation in the middle tier on the IIS box, so you can scale it arbitrarily by adding more IIS boxes. So you get a nice scalability out of that. We don't really do any XSL processing on the back end inside the database itself. However, through mapping schemas, you can actually define the XML grammar and have the database just generate that generically, right? So you don't have to go through a transformation to get an arbitrary grammar out. Like I mentioned, though, there's limitations to that, and there are cases where you're going to need to write that transformation. But there's no magic bullet. I mean, you're going to have to write it some way or another. One thing we are working on is taking that, I mentioned there's a tokenized format in SQL Server, is taking that tokenized format and getting it into an XML document that I can transform conveniently. So I don't have to go to text and then reparse the text. But, you know, there are limitations and there are costs, but the benefits of XSLT, I think, in a lot of cases outweigh the costs.
Thanks, that was very helpful.
In your XML...
Actually, I'm going to have to take it offline because we're out of time. I'll go over here and we can chat.